Today we're going to be talking about the mean absolute deviation. Our learning target is I can find the mean absolute deviation, or MAD, or MAD, when given 10 data points or less. Okay, so the mean absolute deviation is a scatter plot that displays the data so you can visually see the distribution of the data. Okay. The set of the data is the average distance between each value and the mean. And so the way we get the absolute deviation, we're going to get the mean 2 times. So we're going to find the original mean, and that's what step number 1 says. And step 2 is we're going to get the difference between each data set, a data value, and subtract it to the mean that we got in step number 1. Okay. If you get a negative, just switch it to a positive, because this number must be positive. Okay. And in step number 3, we're going to find the mean again of the numbers of the difference between the data value and the mean. Okay. So we do the mean absolute deviation because it will help us understand whether a data set are they similar to each other, or is there going to be a possibility that there's an outlier in this data set. So if your MAD value, once you take the mean twice, if it's a small value, that means that this is a good measure to use when given the data set. Okay. If the mean absolute deviation value is larger, then that means that it is not a good measure to use when given the data set. Okay, so that means that the further away the values in the data set to each other, the more likely that there is an outlier in the data set. Okay, and that's what you don't want. Okay, so we're going to do a few questions together so that way you guys can see how this works. And so first, we have this data set 8, 10, 20, 13, 17, and 18, and we're going to find the absolute mean deviation. And first step is just find the regular mean, and mean is going to be the average. So here we have step 1, which is add all the numbers. So we're going to add 10 plus 18 plus 20 plus 13 plus 17 plus 18. We get 96. Okay. When we find the mean, we add all the numbers and then we divide by how many there are. There are 1, 2, 3, 4, 5, 6 numbers, so we're going to divide by 6, and we get 16. Okay, and so step 2, we're going to use this 16, and we're going to find the distance from the mean. Okay, so these are all of our data sets, right? And we're going to subtract them from 16. So first we have 10 minus 16. We get negative 6. We don't want a negative, so I'm just going to put a 6. Okay, then the next one we have 18 minus 16, we get a positive 2. It's positive, so I'm going to keep it as a positive. Then we have 20 minus 16, which is a positive 4. That's good. And then we have 13 minus 16. That gives us a negative 3, but we want it as a positive, so I'm going to put it as a positive 3. And then 17 minus 16, which is 1. And then 18 minus 16, which is negative 2, but sorry, it's positive 2. 18 minus 16 is 2. Okay. Once we do that, we're going to use these numbers, the mean, and we're going to get the, not the mean, we're going to get the distance from the original mean, and we're going to get another mean. Okay. So that's why it says the mean absolute deviation, right? Because we're going to see the distance between the mean, and we're going to get the mean of those. So we're going to add 6, 2, 4, 3, 1, and 2. Okay. We get 6 plus 2 plus 4 plus 3 plus 1 plus 2 is 18. There are 1, 2, 3, 4, 5, 6 numbers, so we're going to divide 18 divided by 6, and we get 3. Since 3 is a low number, this is a good, there's likely no outliers, and it we're going to use these words right here. Right here, it's a good measure to use when we put it on a graph. Okay. So what this means is if I decide to draw a graph, I can just start with my numbers, like my x values and everything. And I can start with 3, right? And then just keep on going. And so if I use this deviation, this distance between each point, right? It will be a good deviation because of these numbers right here. These numbers will fit really well if the spacing between the numbers in the number line are by 3s. Okay, that's what that means right here. Okay, let's go ahead and do another question. Let's do this one. It says, a group of 7 families on Stephen's basketball team sold magazine subscriptions to raise money for their team. And so we got 1, 2, 3, 4, 5, 6, 7. We have 7 data sets, data values. And we're going to find the absolute mean deviation. So first I need to add all these numbers and divide by how many there are. Okay, that's our first step. So let's do 64 plus 98 plus 11 plus 28 plus 24 plus 13 plus 98. We get 336. We're going to divide by, we said there was 7, right? So we're going to divide by 7. So we got 48. 48 is the number that we're going to subtract each number to get our new deviation. So we're going to get the numbers here, right? And we're going to subtract 48. Okay. So the first one, we got 64 minus 48. We got 16. 98 minus 16. Oh, sorry, 48. We got 50. We got 11 minus 48. We get negative 37, but we want it as a positive, so we're going to put positive 37. Then we got 28 minus 48. Negative 20, so I'm going to change it as a positive 20. 24 minus 48 is negative 24, so I'm going to positive 24. Got 13 minus 48, 35, and 98 minus 48 is 50. Right, so these are the difference between the mean and the data sets that we have up here, right? Now we're going to get the mean of these, right? So we're going to get 16 plus 50 plus 37 plus 20 plus 34 plus 35 plus 50. Okay, so let's do that real quick. 16 plus 50 plus 37 plus 20 plus 34 plus 35. Oh, that's 24, isn't it? (24) plus 35 plus 50. That equals 232. We're going to divide by 7. we get 33.14. Okay, let's just do 2 decimals. Using the mat is the mean a good measure for this data set? So here, let's see. Here, since 33 is not a low number, but still not a high number, it's still lower than 50, right? So I would say this would be a good data set, but it could be better, right? So we know that if we had like a little graph and we want a line graph and we wanted to do like these little tick marks here, we would start at 33, and then the next one would be like 66, and then 99, and then 132, and then the rest would be over here, like, right? Because that's all we have, right? So from 33 to 132. So here, if you write it out and we see like it's not really much of a distribution, then we would say maybe it's not a good measure. Okay, so I know I did say it was a good measure, but now that I see it written out, like this is not a good distribution right here, because it only gives me 4 numbers, and in my number set I have 7, right? It's really hard to really see the distribution between those data sets. Okay, so if you're ever on the fence, just draw out your number line and use your mean absolute deviation to see if it would be a good measure or not. Okay, let's do one more. Go ahead and do this one right here. Okay. It says Linda was asked to create 2 sets with the following, but the following must be true. So set A has a mean larger than set B. The mean absolute deviation of set A is smaller than the mean absolute deviation of set B, and each set must contain 5 points. So go ahead and find the MAD for set A and set B and see if these 3 criteria meet. Alright, so I have both set A and set B for their mean and then their MAD, right? So for set A, my deviation would be 11.86, and for set B, I have 14.56, and so we're going to check each one. So set A has a mean larger than set B, so A is not true because it's not larger. The mean absolute deviation, set A is smaller than the mean absolute deviation. Oh wait, I read that wrong. The set has a mean larger than set B. So here the mean is 36.4 and 34. So yes, that is true. That is true. Okay. The mean absolute deviation of set A is smaller than the mean absolute deviation of set B. That is also true because this one is 11 and this one's 14. And then each set must contain 5 data points, which they both do. So which statement is correct about the sets that Linda created? The 2 sets meet all the criteria given to her. Yep. And then the others are wrong because, it's a multiple choice question.